Picking up on question 22, Costco installs automobile tires on a first-come, first-served basis. The total time a customer needs to wait for the installation to be completed follows the normal distribution, with a mean time of 106.3 and standard deviation of 18.5. What is the probability that a randomly selected customer will wait more than 125 minutes? So we're looking for the probability that X is greater than 125. So if we were to draw it, our mean is 106.3 and 125 would be to the right. And we're looking for the greater than side, which means when we look it up on the table, we're going to get the less than side. So we are going to have to subtract. Okay. And so let's get our z-score because that's the only way we can look it up. 106.3, 125 minus 106.3 divided by 18.5. And when we get that, when we put that in the calculator, we should get 1.01. So when we look this up in the table in a second, it's going to give us the less than probability. So what we're going to have to do is, we know that our probability plus the less than probability is 1. So we can take 1 minus what's on the table to figure out the greater than side. So on the table is the less than side, always. So 1.01. Now we're going to go to the positive, which is right below it. 1.00 is 0.841. 1.01 is right here, 0.8438. So the purple is 0.8438. So our side is going to be 1 minus 0.8438. So the probability of it being greater than 125 minutes is 0.1562. So the probability that a customer is going to wait more than 125 minutes, there's about a 15% probability, and I hope that I wouldn't have to wait that long. Okay, number 24 is basically the same thing, but we're doing the less than side, so it's actually a little bit easier because what's on the table is really what we need. So with that being said, we have the mean is 387.20 and the standard deviation is 68.50, and we want to know the probability that these two cities will be less than 300. So to get our z-score, and let's go ahead and draw our table down here. The mean is 387.20, and ours, we're looking at 300, and we're looking at less than, which is exactly what we want. So we need to get our z-score. We know that the mean z-score is 0 standard deviations away because it's right there. So we're going to do z equals 300 minus the mean divided by the standard deviation, which is 68.50. So that should be a negative number because it is to the left, and when you calculate it, you'll get negative 1.27. So you go to your table, you go to your negatives, and find negative 1.2, 1.20, 121, 22, 23, 24, 25, 26, 27. So 0.1020 is our answer. So the probability that x is less than 300 is 0.1020. Okay, moving on to the next one. Bananas, 48 per bunch. The mean is 3.54 pounds. The standard deviation is 0.63. What is the probability that it's going to weigh less than 4 pounds? So if we were to do our normal distribution, 3.54 is here, 4 would be somewhere over here, and we want to know less than, so when we get the number on the table, that is our probability. This will be 0 as a z-score. To get your z-score, you're going to take x, which is 4, minus the mean. It should be a positive number because it's to the right of the mean. So you get 0.73. So let's go to our table and go to 0.73. 0.70, 71, 72, 73, 0.7673 is the probability, I forgot to put that, the probability that x is less than 4 is 0.7673. Alright, now looking at the next one, the Costco one, the total time a customer needs to wait for installation. The mean time is 106.3, and the standard deviation is 18.5. What is the probability that the customer will wait less than 100 minutes? So, 106.3, 100 would be to the left because it's less than. Now let's get our z-score. So we're going to do 100. It should be negative because it's to the left of the mean. And so our z-score is negative 0.34. So our probability, we're wanting the less than. So all we have to do is go to our table, go to the negative, 0.30, 31, 32, 33, 34, 0.3669 is our answer for that one. Okay, sampling error is pretty straightforward. You're going to take your sample mean and subtract your population mean, and that's going to give you your sampling error. Now, to get your population mean, you're going to add all your numbers up, and when you add all your numbers up, you're going to get 168, and you have 24 numbers. So your population mean is 7. Now, so 7 is going to go here. For your sample mean, you're going to do the first row. You're going to get that sample, 3 plus 8 plus 2 plus 8 plus 11 plus 7. I think that is going to be 26, 28, 30, 39. So 39 divided by 1, 2, 3, 4, 5, 6 is 6.5. So 6.5 minus 7 would be a sampling error of negative 0.5. For the next one, it would be the same thing. You're going to add all your numbers up and get your average. So you're going to do 54 divided by 24, and you're going to get 2.25. Now for this sample mean, you add those up, you get 15 divided by, there's 6 of them, you get 2.5. So this is your population, this is your sample, so you would subtract those. So your sample minus your population would give you a sampling error of 0.25. On this one, they're wanting you to find the standard error of the mean for the sample, and the standard deviation is 68.2, and N is 43, and that's all you have to know to do this one. and you will get 10.4. For the next one, Experian, your standard error of your mean, your standard deviation is 46.1, and your sample is 60. So 46.1 divided by the square root of 60 is 5.95. On number 28, we're doing a population standard deviation. What is the probability that the sample mean will be greater? So what is the probability that the sample mean will be greater than 1450? So we have a random sample. We have N is 39. We have the average rent is 1,531, and we have the population standard deviation is 227. So what we're trying to do here is, first we have to find the standard error of the mean, which is the standard deviation divided by the square root of n. So that would be 227 divided by the square root of 39, and I believe we got 36.35. Then what you have to do is get your z value. So you're going to do your mean. We're looking at the be greater than 1450. So x is greater than 1450. So we're going to do the mean, x minus the population mean divided by the standard error of the mean. And when you do that, you're going to get z is negative 2.23. I'm not going to draw the curve, but remember, if it's greater than what we get on the table, we're going to have to say 1 minus that. So if we go look up negative 2.23, 0, 1, 2, 3, we get 0.0129. So we're going to do 1 minus 0.0129, which is 0.9871. Number 30, the average gas bill for a random sample. They're just wanting the standard error of the mean on that one. So you would do the standard deviation divided by the square root of n, and that would be 5160 divided by the square root of 21, which is 11.26. A little bit off. 27 would be you would pick the closest value there. So if the population standard deviation isn't known, you're going to use the t-distribution. So it's similar to what we've been doing, but with a little bit more. You have degrees of freedom, which is n minus 1. So n here is 21 minus 1 would be 20. So what we're going to do is we're going to find the standard error, which is going to be, we're going to replace the standard deviation with the sample standard deviation, and you get 11.26, and we said our degrees of freedom is 20, and we know that the mean is 311.90 plus or minus whatever we get for t times the standard error of the mean, which is 11.26. So you'll have to look the formula up for that. I'm going to show you on the table where to find this. So it's right below the normal distribution. You want to look under the 90% confidence interval and find degrees of freedom to the left of 20. So you would get, here it is, 1.725. So we're going to put 1.725 here. And then your confidence interval would be 292.46 and 331.34. It may be off a penny or two on that answer, but it's very close to those numbers, if not exactly.